looping. If you have any experience with looping in programming language, you will find Python's way of looping a bit different. First of all, what's looping? Looping means being able to repeat the execution of a code block more than once, accordingly to the loop parameters were given. There are different looping constructs which serve different purposes, and Python has distilled all of them down to just two, which you can use to achieve everything you need. These are the for and while statements. The for loop. The for loop is used when looping over a sequence, such as list, tuple, or collection of objects. Let's start with a simple example and expand on the concept to see what the Python syntax allows us to do. So let's create another file called looping. Okay. In this case, simple for loop. For.py, okay. I wanna say for number in, I don't know, some numbers, okay. For and tag colon and same print number. So let's say pipe simple, and you will see that we are printing 0, 1, 2, 3, 4, 5. This simple snippet of code, when executed, print all numbers from 0 to 5. The for loop is fed to the list 0, 1, 2, 3, 4, 5, and at each iteration, number is given a value from the sequence, which is iterated sequentially in order. Then the body of the loop is executed, I mean the line 2. The number value changes every iteration accordingly to which value is coming next from the sequence. Then, when the sequence is exhausted, the for loop terminates, and the execution of the code resumes normally with the code after the loop. Of course, another way to say to do the same thing with a Pythonic way is saying of using the function range, which generates a list of values from 0 to 5. Okay. Now let's add a little of complexity to the game. I want to create a new file called simple for 2.py, but in this case I want to work with strings. Surnames equal to list of surnames, rivers, submit, and adult name. Now for position in range, I wanna say list of surnames, okay, in plural, the surnames. Then print position and surname, and with the position in each iteration. So let's print it. I want to say pi simple for 2. Okay, let's look what happens. Okay, I type it. It's not list. I wanna try to say length. Okay, well, and you'll see in the output 0 reverse, 1 submit, 2 adult men. Of course, if you wanna do it in a Pythonic way, you can use the function enumerate like this. Enumerate, and in this case, we've got here position and surname. Okay, I don't need this anymore. Surname, and let's try it again. Yeah, I enumerate is the correct function. Okay, we've got the same output: 0 rivets, 1 sharp meat, and 2 Edelman. This is of course a very interesting way of doing the same thing. Notice that enumerate function gives back a two tuple position in a surname. You've got here position and surname, which is the value of the list. Okay, and also is in iteration, of course, but it's more readable than using range length as we got before. The while loop. In the preceding pages, we saw the for loop in action. In the preceding examples, we saw the for loop in actions. It's incredibly useful when you need to loop over a sequence or a collection. The key point to keep in mind when you need to be able to discriminate which looping construct to use is that for for loops is that the for loops works when you have to iterate over a finite amount of elements. It can be a huge amount, but it's still something that ends at some point. The while loop. In the preceding example, we saw the for loop in actions. It's incredibly useful when you need to loop over a sequence or a collection. The key point to keep in mind when you need to be able to discriminate which looping construct to use is that the for loop works when you have to iterate over a finite amount of elements. It can be a huge amount, but it's still something that ends at some point. The while loop is similar to the for loop in that when both loop and at each iteration they execute a body of instruction. What's different between them is that the while loop doesn't loop over a sequence. It can, but have to write a logic manually, and it wouldn't make any sense. You would just want to use a for loop. Rather, it loops as long as certain condition is satisfied. When the condition is not longer satisfied, the loop ends. As usual, let's see an example that will clarify everything for us. We want to print the binary representation of a positive number. In order to do so, we want to use a simple algorithm that collects the reminders of division by 2 in reverse order, and that turns out to be a binary representation of the number itself. So let's create another file called binary. That's file. Then I wanna say I wanna print number 39 in binary. Reminders equal to an empty list. I wanna say while and it's higher than 0, so reminder is equal to n percentage of mode to 2, the reminder. Reminders dot insert 0 or reminder then I wanna say the number // 2, which is an entire division. Okay, now let's print reminders. And then execute this file like py.binary, and it will print 100111, okay, which is the binary representation of the number 39. You can use any kind of binary converted to decimal, binary to decimal converted in online, and when you will check that this number is 111 compared to the decimal is equal to 39, which is our number in the line 1. Okay, of course there is a Pythonic way for this example. You can use the deep mode function in order to return the entire division and the remainder of a function of a number of a division, like deep mode equal to, well, you need to pass n and then 2, and that's it. You can say, you can comment our last code and then execute it again. Of course, we need to add the number to the reminders. Okay, reminders list like this. Actually, the function dmode receive a number and a divisor. It returns a tuple with a result of an entire division and also its remainder. For example, in this case, we are passing our number 39, and we return the division 39 and 2 in the first index, in the first position, and the second position it returns the remainder, which is inserted into the reminders list. Okay,